I'd like to thank Bentley for giving us the opportunity to present this project. We're very proud of it. It is the first wind farm on the offshore for the United States, and we're very proud about it. Just one quick note to kind of put it all in perspective. When that top blade sweeps the tip of it, it's the height of a 50-story building, so it's quite large. And I don't know if anyone's seen the wind turbines on land, but the ones offshore are very, very large. Kind of tell you about our company. We're not a very large company. We're a basic oil and gas petrochemical company. Started in Louisiana 27 years ago in New Orleans. We have offices from New Orleans all the way to Houston. And the oil and gas industry has been our bread and butter for a long time. So you may ask, so why wind? Why did we go into wind? Well, a few years back, our business in the Gulf of Mexico was kind of playing down. The Gulf of Mexico is a very developed, mature site, so we had to figure out a way to keep jobs and keep making money. So we started looking into this the whole wind side of the business by accident, actually. One of the founders of our company had an acquaintance over in Europe that was familiar with a concept that we had developed for the Gulf of Mexico for minimal structures. And he told us, look, there's a competition they're going to be having over in Great Britain. The Carbon Trust is putting on to see for the next round of offshore wind farms that they're having in Europe. The first round were caissons, basically one big pipe. And as you get deeper and deeper, the water gets deeper and deeper, you can't use the caissons, they get too large. So the next round had to be a jacketed structure or something similar to that. So there was a competition to see what would be the best result. So he said, look, you guys have a concept, so maybe that might work out. So our owner, Rudy Hall, who had been in the oil industry a long, long time, started putting it together. Right about that time, I actually came to the company. I'd worked for a long time for another oil and gas company, and got with Rudy. We talked about it. I am a structural engineer, had a lot of interest in it. So I told Rudy, I said, well, you go ahead and do that. I'll go ahead and make money for the company, and you go off and try to figure out a way where we can make money down the road. So that was his job for a number of years. Now this was back in 2007, 2006. The competition was entered in 2009. We were actually successful. We were one of the finalists. And from that, we actually went in and installed a structure in the English Channel for a met mast for a round of platforms that will be coming up in the future. So that was our first, I guess, opportunity in the wind industry. Since then, we've gotten really aggressive with it, and we've gone all over the world trying to let people know that we can design these platforms. So that's how we got into it, by necessity. So innovation sometimes is because of you need a job. So what is the project? It's off Block Island. It's a small island off the coast of Rhode Island. And we're going to put 5 platforms out there, each with 6 megawatt Alston turbines. We're going to have about 30 megawatts of power, and we're going to power 17,000 homes. And one of the unique things about this job is that, and really one of the difficult things about the offshore wind industry in the United States is it has to be, they really drive you to be economical. And this job is unique is because it's actually economical. One of the reasons for it, all the energy on this island is produced by diesel electric generators, and all the fuel is brought over by ferry. So if you can imagine, the cost of that's pretty high. So this project actually will be economical. So it's met all the hurdles, and we've gone through, and we're actually out there installing it right now. Here's kind of the timeline for the project. We started design first quarter 2014, started fabrication in the fourth quarter of 2014. The fabrication was done by a fab yard in Houma, Louisiana, South Louisiana. One of the real issues we have is infrastructure on the East Coast. There's very few fabrication yards that do this type of construction. So we had to do it down in Louisiana and ship it up that way. And we're right in the midst of installing the jackets now. And our target was to get all the pile driven by the time the wells started migrating down the coast, because they don't like that pile driver hitting that pile. So we did make that and had all the piles end up. And then we'll continue on, and the turbines will be installed in Q3 2016. So that's the timeline for the project. Here's the location. Again, it's off the coast of Rhode Island. And this particular 5 platforms is the start of an even larger project called Deepwater 1, which will have 1,000 megawatts of capacity. And we'll, depending on how the progress of this and the success of this, we'll carry on, and hopefully we'll be involved in that part of the project. What is the opportunity for wind? If you look over here in Europe, Europe is well beyond where we're at as far as wind, just because of the need. The United States has all these, plenty of oil, plenty of resources, so we haven't had that real need. But over in Europe, you've gotten to have that need, and you started doing this thing in 1991. You've got 10,000 megawatts connected out there, so you have a very robust offshore wind industry. It's keeping a lot of people employed, and they're doing it without even being economical with nuclear energy right now, but they plan to be economical by 2020. That's 5 years down the road, not very far down the road. So that's the opportunity in the world. The interesting thing about it, since we don't have a real robust offshore, we have a very robust onshore. We're the largest producer of wind in the world, which, I'll be honest with you, 2 or 3 years ago amazed me. I didn't even know it. We have 70,000 megawatts connected. $100 billion invested since 2008. It's very robust business, 75,000 jobs, and it is economical with nuclear now on land. And here's kind of what we're looking at in the United States and what we've gotten involved with. If you kind of look, the map on the left, the red areas, the darker blues, those are where you have what they call good wind fields. The wind is blowing at a constant rate, the right rate, to where you can produce energy fairly efficiently. And the map on the right is where our populations are centered at. Now, the interesting thing, right in the middle of the country has our best wind, but there's not many people live there. It's in the middle. It's in Montana. So, but there's still wind farms out there. So, if you look at where our onshore has really taken a lot of progress, it's in the Texas, Oklahoma, pretty much all over the interior part of the United States. It's taken off. So the obvious areas that we're really looking at right now are the East Coast. There is a prospect out on the West Coast. Amazingly, that's going to be a floating platform, and it's slowly developing. The hope is that you'll have 30,000 megawatts installed by 2030. That's not too far down the road. That's 15 years down the road. $200 billion in investment, 43,000 jobs. And the real interesting part, it'll eliminate 2 million tons of CO2 put into the air. Now, right now in the United States, it's kind of a big discussion back and forth. The oil industry might say, yeah, you don't have to worry about the global warming. They really push that. But in reality, it's something we should be worried about. So one of the things that we've learned as a company is that these are things that we all need to be doing. So it's given our younger group, and our offshore renewable group is a younger group, a lot of energy to try to do what they think is the right thing. So that's part of our innovation, developing a concept that will allow us to put these wind farms out there. So let's kind of look at the challenge we have with putting these offshore wind farms out there. Obviously, you have a real complex wave loading. Not to mention you have every once in a while, a 75-foot wave come through every once in a while to slam the platform. And then the complex wind loading, that's the turbine spinning and the actual aerodynamic properties of the wind going around the blades. Those two areas are very, very complicated. And if you look at where we are in the United States, we have a pretty good grasp for the wind loading for our onshore, and that's basically from the foundation up. And in the oil and gas industry, we have a really good understanding from the bottom of that mast down, because we've been doing structures offshore for quite a long time. But when you look at how they interface, they sometimes they're 90 degrees each other. They're very complicated. So coming up with loadings to simulate this type of structure is very, very complicated. So what we have to look at is what is the solution? Now, one of the things I want to note is Keystone prides itself. We've done a lot of structural analysis, and SACS has been our software for a long time, and we've developed a really good relationship with that company. Before Bentley was there, it was another company, and what's been really good about Bentley is the relationships we had with the company before Bentley have continued on, and it's been very instrumental in helping us make this jump from the oil and gas part of our business to the wind industry. This solution is very, very complicated. And to kind of give you an idea of what's going on there, you have to go in there and simulate these two forces coming together. There's 2,334 simulations for this particular platform, 30,000 time steps. So what you have to do is you can't just say, well, here's the loads, let's check this thing and it works. No, you can't do that. You have to go in there and simulate the entire life of this structure, 20 years. So there's 30,000 time steps. So if you have to do an analysis, 30 million, if you have to do 30 million time steps, back when I first started, when you're still doing it by hand, that would take you a long time. So what we've done is we've gotten with Bentley, and we work with them to help us do the load accounting that comes with the simulations, and also take their software and adapt it to faster computers, which is the real key. When we first started doing these analysis maybe 5 years ago, the computers were, a typical IBM computer that most people do analysis on. The ones we have now, I refer to them as souped-up computers. They're dual processors. They're extremely fast. And you just don't throw your software on there. Bentley had to take the time and effort to modify their system, modify their software to do that. And they've been very, very instrumental to us getting to where we're at right now. Again, the waves on this particular structure will get up to 19 meters. If I'm doing my math right, I'm still thinking in feet, right? It's over 60 feet. So here's the three modules that we utilize when we're doing our analyses. Obviously, we use their wind programs to do the actual analysis of the actual structure. And what you're having to do is you're having to go to the turbine manufacturer. He'll give you his loads all the way down to the bottom of his mast. The way they work is they'll do everything to the bottom of the mast, and us as the design company for the foundation, we have to take that load, apply it to our structure, and that's from maybe, let's say, 60 feet above the water all the way down to the seafloor. So we have to take that, and Bentley has helped us do that with their wind turbine analysis, do all the load counting. Obviously, we're using their linear elastic software to do what I call the gingerbread, the topside steel. We're using Dynapack to account for all the dynamics, and you can imagine there's a lot of dynamics with this type of structure. We use their analysis for transportation and also for impact analysis for these structures. There's, all the code requires us not only to analyze it for all the environmental conditions, but just in case something hits it. So this is what we ended up with. We ended up with a deck structure, which is this top piece. I don't know if I can point it out right there, but it's from, I guess, that yellow boat landing up. That's the deck. It's about 350 tons. And then down there's the jacket. It's about 400 tons. And one of the things we've calculated, of course, there's only so much data we can get, but we're estimating we're about 15% lighter than a typical 4-pile structure like this used in other areas of the world. So we're going to put that credit to our good design team and Bentley's assistance. And it has a 20-year design life. One interesting thing about the new software, the capability that Bentley's added to their software, is our original analysis might have taken 1.5 years. This analysis was done in about 9 months, so it certainly saved a lot of time. So here's some pictures of where we're at. Here's the fabrication being done. This is the deck structure in Houma, Louisiana. They're not quite ready to paint it, but they're working on that. Here's a picture of the jacket, and it's being all set up. I don't know if you can see, but you can see the anodes because it's underwater, keep it from corroding. And here we're getting ready to load it out. We're putting it on dollies, and we're going to roll it out onto a barge. And here it is being rolled out onto the barge, all the structures and the piles. And here it is being installed. So it had to be transported from Houma, Louisiana, South Louisiana, New Orleans, all the way up around Florida, up the East Coast, and now it's in the process of being installed. So here it's being set by a jacket, a derrick barge. That little derrick barge is around 600 tons. Very small when you look at what the derrick barges are in the Gulf of Mexico. They're up to 10,000 tons. So it's the industry as far as offshore wind is just starting to develop infrastructure. The next picture you see there is a lift boat from South Louisiana that's driving the piles. So we had to bring a lift boat up there because we didn't have a vessel of that sort. And here we are right now where we're ready to receive the deck. It's been cut off. And I think we have some more pictures. One of the things I want to note is the actual project engineer that was going to give this presentation. His name is Zach Finucane. actually had to go offshore for this and did not come in. So he's snapping pictures and sending to me as we speak. So I think this presentation has been modified maybe 2 or 3 times over the last hour. Here's some pictures he took. Last night they just lifted up the deck and set it. So it's like a time-lapse picture. So they're picking it up off the barge with the 600-ton derrick barge, and they're setting it, and then they're going to weld it out. Now, once these are all installed, and they're planning to get installed, the 5 platforms, before the weather gets really bad this winter, next summer, they're going to bring a Norwegian vessel in to set the mast and the turbines. There's no vessels on the East Coast with that type of technology. You have to be a fixed bottom type platform to make the installation because it's very, very critical, very, very motion sensitive. So we're going to have to bring in a Norwegian barge to do that. And that's the end of the presentation.